Hey guys, let's talk about your assignment for the day. So this is a self-grading assignment, meaning that when you type the correct answer in, the box will turn green, and then when you turn it in and it's all green, I know that you've done it correctly. So we just talked about polyatomic ions and also naming ionic compounds. Remember, if it ends in IDE, that means you've just got one cation and one single anion. And if it ends in ITE or ATE, it's going to be a polyatomic. Spoiler alert, all these are polyatomics because we need to do some practice with them. So basically, there are some empty places here that we're going to fill in today. I have already filled in some of them for you, so that's why you see a 7 out of 20 here, because I left some in here to help get you started. So when you're done, if it's all correct, it'll be a 20 out of 20. Okay, so for the top part, you are filling in the cation symbol. So remember, your cation will come from your metal. So you just have to look at the metal and the compound name. You will then use your periodic table to figure out what period it is in. And then, of course, how many valence electrons it will donate. All of your cations will be positive, right? Your anion symbol will be your polyatomic anion. Remember, you will use your common polyatomic ion sheet for that, which is right here. It's linked in your lesson. And then your compound formula, you have to put it together. Remember, you use your swap, drop, and chop method. Remember, for the polyatomics, you will just put it into parentheses and do it that way, right? So it already gives you your cation and anion symbol. If it wants the compound, you just have to put it together. Now, that's for the top. For the bottom, you have to use your naming rules in order to name the compound. Again, because these are going to be polyatomics, you're going to want to use your polyatomic sheet for this. Okay, so let's do a couple examples together, and then you can do the rest on your own. So our first one, we have sodium chlorite. So our cation is sodium. I know it's a +1 because he's a alkali metal in that first group. So he's got one valence electron, which he's going to donate. So his charge is a +1. Our anion is chlorite, whose charge is a -1. Now here you don't have to worry about doing the super and subscripts. You just write it all as one thing, so it's easy peasy. So here for my compound formula, remember if we do our little lasso, so if I have Na +1 and then ClO2 -1, remember the +1 becomes the subscript over here, and then our superscript of our chloride comes over here. So if we were to write this down, it would just be one sodium, and then ClO2 because it's only one. And that's correct because it turned green. So you only needed one of each. Now, because this is only one, I didn't put parentheses around it. But if you notice, like in magnesium nitrate down here, there are parentheses around the polyatomic ion because there's multiple of them and we want to make sure that we can keep it all straight. Okay? Now for calcium carbonate, you've already got the calcium. You've got the carbonate here. You've got the compound. It's just asking you to identify the cation in this one. Calcium, I'll show you again how to do that. Let's go find calcium on the periodic table. Calcium is right here. Calcium is in the second group, which means he's got 2 valence electrons. Cations always donate their valence electrons. So since he has 2 valence, he's going to give away 2. And that means he's going to have a +2 charge because we're getting rid of those negative electrons. So he's going to have a +2 charge. So we're just going to say Ca and then +2 because he is calcium and he's going to have a +2 charge. That's correct. It's green. We know we're good to move on. Okay. Last example up here, we've got magnesium nitrate. So here's our magnesium and our nitrate. So we know this is our polyatomic. So our polyatomic is going to be NO3, and that's nitrate. To get the charge for the polyatomic, we have to go to our polyatomic ion table, okay? And we just have to find nitrate, which is right here. So nitrate is NO3, which we figured out from our formula. And then if we see this negative here, -1, that means nitrate has a -1 charge. So in our table, we're going to do -1. Okay, and that's how you find your anion. So the cation comes from the periodic table. You just have to understand how to figure out the charge. The anion charge is going to come from your polyatomic table. And then the compound formula comes from your swap, drop, and chop. Okay, now on the bottom, these are all naming. So 11 through 20 are naming. Again, remember your naming rules are metal goes first. K is potassium. So potassium. And then we have to figure out what our polyatomic is, right? So we know that potassium is the metal. So C2H3O2 is going to be our polyatomic. So let's go find C2H3O2. C2H3O2. And sometimes, I actually don't remember where it is on here. It's going to take me a minute to look for it. C2H3O2. Oh, perfect. It's right here. So C3, or was it C3? Hold on. C2H3O2. C2H2, yeah, it's this one. It's acetate. So C2H3O2 is our polyatomic, so that's acetate. So we will write acetate here. So you just have to take the name from the polyatomic, and that is correct, okay? So for the bottom, the first part of the compound name should just be the metal, so like magnesium, aluminum, calcium, and then your anion comes from your polyatomic, and the table will give you the name. So you just find the correct polyatomic, and then you find the name next to it, and you add it. So easy peasy, lemon squeezy. But of course, if you have questions, let me know, and I'll be more than happy to help you.